Okay, so today what we're going to be looking at is how to mesh a pin or a circular object correctly, and then I'm going to give a brief introduction to mesh sensitivity studies, which you'll have to do for your project. Okay, so we'll start off here by making a pin. So we'll double click parts, just call it a pin. It's a 3D deformable solid, so extrusion and approximate size of 200 is fine. So hit continue, click on the create circle tool and draw a circle, and remember to keep the vertex of the circle either vertical of the center point or horizontal of the center point, or else it could affect the way that your mesh is created. So we'll just click that there. We're going to add a dimension to it, and I'm going to call the radius 20 meters. Okay. And middle click to accept that, and middle click again. The depth that I'm going to apply to this then is 100. Okay, and then that's our three-dimensional object. Now I'm just going to create our material, so double click materials, call it steel, and under mechanical properties go to elasticity and elastic. We'll type in 200 E9 for the Young's modulus of 200 gigapascals and a Poisson's ratio of 0.3. Okay, now I'm going to, first I'll just create a mesh on this surface. Seed part. Okay, so we'll see if we mesh this object as it is, then we don't get a very uniform mesh, particularly around the center of the object, and a non-uniform mesh can create stress concentrations in areas where they don't exist in real life. So the aim of what we're doing today is just to create a uniform mesh across the entire object. So we'll just go back into the part mode, and now I want to partition this object into 4 quarters and also partition this surface here. So we'll just begin. That's fine. So just click on the partition cell. We'll partition it with 3 points, and I'm just going to select these 3 points here. Middle click to accept that, and it's split it in half. Now again it says select the cells to partition, so I'm going to select the whole object, the 2 cells, middle click, again 3 points, and select them like that. Middle click once more, and we now have our object split into 4 equal cells. So now I'm going to just partition this surface with another circle on top. So clicking, just middle click to say that that's finished. I'm going to click on this tool, partition face, and it says select the faces to partition, so I'm holding down shift. I'm just going to select these 4. Middle click, and it says select an edge or axis that will appear vertical and on the right, so just click somewhere on the circumference. Okay. Now again use the create circle tool. Remember to put the vertex on vertical or horizontal of the center point. That's fine. So add dimension to that, and this time we'll just call it 7 meter radius. Okay, then middle click to accept that, middle click again. And now we've partitioned that surface, but that partition doesn't run through the whole model, so we want to sweep that partition through the entire object. So any icon that's here in the toolbar that has a small triangle beside it, that means that if you hold the left mouse button down on it, you'll get another selection of tools that are hidden underneath that button. And I want to go to the 4th one in there, which is extrude sweep edges. So we'll select that. Now select the cells to partition, so we'll highlight the entire object again. Select one or more edges to sweep. So holding shift, I'll just select the 4 edges of this circle here. And middle click to accept that. And we'll go with how do you want to sweep, and we'll go extrude along direction. Select one of these lines that are going from the top of the cylinder to the bottom of the cylinder, and there'll be a cone that'll be placed on that, and that's for you to tell Abaqus in which direction you want the sweep to take. So with the cone in its current direction, which is pointed upwards, that sweep would go nowhere near the cylinder, so we would just want to flip that cone so it's pointing down through the object. So go OK and create partition, and now we've split the cylinder essentially into 2 different cylinders. Okay. Now I'll just apply the material properties to this object. So double click sections. Section 1 is fine, it's a solid, homogeneous. Continue. The material is steel, which is the only material that we've created, so that's okay. Now double click section assignments, and it says select the regions to be assigned a section, so highlight the whole thing, middle click, and we'll go with section 1. Okay. Now we just need to instance this in the assembly, so double click instances, and once pin is selected just hit apply and then cancel to exit that. So now we have the pin in our assembly. So so now, okay, we need to create a step, so double click steps and just go with all the default settings, and it's a standard analysis that we'll be running, so static general is fine, so hit continue, and we don't need to click anything in there. So boundary conditions, double click BCs. It's going to be applied in step 1, which is the step we just created there. I just want to create an encastre boundary condition just to fix this end down here so that it doesn't move in any way. So go continue, and it says select the regions for the boundary condition. So just holding shift, I've selected all the portions of the circular face down here, middle click to accept that, and again I'm just going to select encastre. Okay, so that's our boundary condition. Now for the load that I want to apply, double click loads here. I'll apply a pressure, and it's applied during the step that we created, that's okay, so hit continue, and I just want to apply it to one of these quadrants here, so middle click to accept that. The magnitude of that, we'll just say 1000, or we'll say 7 E5, so 70,000. 700,000, okay. And so that's applied that pressure over that surface. So now we need to we'll just create the job. So double click jobs, job 1, that's okay, hit continue, and okay. And now the last thing that we need to do is, mesh the object. So up under parts and pin, double click mesh, and okay, under mesh go to controls, and it says select the regions to be assigned mesh controls. So I want to change the type of mesh that's created in here from the default type of mesh to get using our new partitions to get a neater mesh structure. So holding shift, select the 4 quarters of the inner part, the inner cylinder, then middle click, and we want to change it to a wedge shape, which should slice this up into pizza slice type elements, wedge, and the default there is sweep, so hit continue or OK. And then that's done. Now we need to seed these edges appropriately. So to do that, I'm just going to click on seed, edges, okay, delete. Okay, these are the seeds from the previous analysis that I ran to show you the incorrect mesh. So I'm just going to delete my part seeds. Okay, so now seed edges, and as I select the regions to be assigned local seeds. So I'm going to start by just selecting all the circular elements of the circumference on the inner and outer cylinders. Okay, so that's 8 lines that should be selected. Middle click then, and I'm going to seed it by number, and this time I'm just going to put 6 elements. If we hit apply, that means that you can see that each of the quarters of the circles have been divided into 6 equal sections. So we'll hit OK. And now again it says select the regions to be assigned local seeds, and this time I want to do the vertical and horizontal lines, just the exterior ones first. So I'll select these 4, middle click, and I'm just going to put 4 elements, so split those up into 4 quarters and hit OK again. And now select the regions to be assigned local seeds, this time selecting the 4 smaller horizontal and vertical lines. Middle click to accept that, and I'm just going to put 1 element in there, so that means it's just going to define the center point for me. So hit apply and OK. And now that's my seeding done. So to mesh the part, I'm just going to go mesh and part and OK to mesh the part, just hit yes. And we can see it's created a much neater mesh on the object here. Okay, and so stresses should be relatively uniformly distributed across a mesh like that. Okay? So the mesh will now have no influence on the results, or shouldn't, or won't have as much of an influence on the results as the previous mesh would. Okay? So that's the meshing of a circular object. Okay, so now I'm going to go and talk about the mesh sensitivity study. So we'll just exit this model now, and I'm going to open up a model I created earlier on. So it was just a block, and this face I had fixed to a wall in Encastre, so it wasn't going to move in any direction. And if I click on loads here, you can see I just created a load on a partition part of this surface on top here. So basically it's just quite a thick beam under bending. So if I now going to go back into the mesh module, and I'm going to delete my current mesh and just hit OK. So when I now click mesh and part, middle click to accept that, it says here on the bottom that 240 elements have been generated on part cube. Okay, so now I'm going to have an Excel file open, and this is going to be my roughest mesh here. So in the Excel file, I'm going to say the first mesh had 250 elements, and I'm now going to run the analysis with that number of elements. Okay, so I've just submitted my job there. And I'm going to right click on the job and go to results. View my results here. And then look at the maximum stress. So I'm just going to hit the contour options box beside the contour plot. And under the limits tab, it should say there maximum stress of 182,571. That's down in the bottom hand corner of the edge that's fixed to the wall. So 182571. Okay, so that's created a point on my plot there. Now I'm going to increase the mesh density. So going back into my part, double clicking on mesh, seed part, and I'm going to go down to approximate global size of 3, hit apply, delete mesh, okay. Mesh part, yes. And so now we can see it's a finer mesh on the model, and we have 1120 elements. So I'm going to add that in here, 1120 elements, and I'm going to submit this job. And the job is completed, so right click on that and go to results. Okay, the maximum stress is in the same location. This time the value is 216458. So I'm going to add that information then into the Excel file. And now to increase my mesh density once more, go to part, double click mesh, seed, part, and if I hit apply with a global size of 2 and mesh the part once more, that's 3600 elements. And submit my model again. The point of doing a mesh sensitivity study is that the more elements that you have in a model, the more accurate your results will tend to be. However, it'll take longer to calculate the maximum stresses for your model. So there comes a point where adding elements to a model will not increase the accuracy of it. So you just have to find the number of elements that gives you a good result and reduces computational time. So again, now I'm going to right click and go to results for this analysis. Look at the maximum stress here. This time it's 247025. 247025. I'm going to add in another mesh here and just call it mesh 0. When you're doing this actual analysis, you'll probably have a lot more meshes that you're testing it over. I'm being fairly rough with it, but just showing you how to do it, or the general concept of it. Okay, and now back into part, double click mesh, seed part, going to put a rougher mesh on it, delete mesh, okay, mesh part, and we can see it's a very rough mesh. I'll submit that. Right click on the completed job and go to results. Okay, if I just scroll up here, I can see that time it created 84 elements on the model. And the maximum stress this time is 162473. just going to include that data here now. Okay. And now to do the finer mesh again. So back into part, double click mesh, seed part, and I'm just going to give it an approximate global size of 1. Delete the current mesh, okay, mesh part. And we can see this time that the mesh is very fine on the object. So now I'm just going to submit my job once more. So you can tell it's taking longer to run this time. Okay, it also says there are 28,800 elements. So I'll just add that in here. 28,800. The job has been completed, so we'll go to results. And the maximum stress this time is 313,303. So 313,303. Okay, so that's as far as I'm going to go with the mesh sensitivity study, but essentially you can see that as the number of elements increases, your maximum stress and accuracy of the model will increase, but it definitely does begin to flatten out. So you can see in the beginning there, between 0 and 5,000 elements, there's quite a big change in the results you're getting, and then that begins to level out over time. So essentially for the mesh sensitivity study, you just have to find a point where you're happy with the accuracy. So basically nothing down in this region for this model. And that's it for today then, okay? See you soon.